This conference will now be recorded.
Hello friends, welcome to the next session. So in today's session, we'll be looking at mathematics for data science. We'll start understanding what are the basic mathematical concepts, specifically looking at a data science perspective. We'll see like where all those areas are used. And if time permits, we will start understanding about linear algebra, which is one of the basic mathematical concept. And we will go in detail. So this week we will spend more in detail about different other mathematical concepts. We look at linear regression, distance metrics, eigenvalues, eigenvectors, and calculus, differentiation, and their uses in data science. All those things we will be covering in today's in this week's content. All right. So just give me a second. I'll just share my content. Just give me a second. I'm not speaking anything. I'm just setting up the system. There's a slight problem with the pen actually.
Hi, Sitaram, can you hear me? Sitaram, can you hear me?
Hi,
Just a
Balaji.
second, kindly hold on for a few minutes. I'm just setting up things.
Sounds good. Okay, thank you.
Apologies.
Yeah, I just want to make sure, like, the mic and speaker are working.
Okay. So apologize for a little delay. There is some settings problem in my system. I was not able to recognize the pen and I was not able to present it properly. I'll ensure that the next time it would be set properly. So let us quickly start our topic for today, which is mathematics for data science. Maths for data science. So math for data science is basically, what we are talking here is the foundational concepts about mathematics which will be used in data science. The first and important component which will be learned is the linear algebra. Now we will be going again back to our school and college days and we will be looking at these concepts, but basically our focus will be on focus will be on like how these topics would be used in the data science parlance. Algebra, and specifically we will be talking about scalars, vectors, tensors, and other kind of metric related operations. We would be looking at matrix operations, and so on. So a lot of these different metrics and metrics related operations are very common in the data science view, because everything whatever we are considering, we will be treating it as a matrix. For example, you get a data from your business, you get a Excel sheet from your client, or maybe a database dump, or a CSV file, or a JSON script. So whatever you are trying to get, those all information we will try to convert into a matrix, and on the matrices we will try to do operations. So the matrix could be having rows and columns. So R1, R2, R3, R4. And different rows and columns will be there, row 1, row 2, row 3, and row 4. And based on different column names I'm saying. And then this data will be taken, and then you will be doing some operations on the number data on in the matrices. So we will see like what are the operations which will be done on these matrices, how we can represent the matrices, how we can represent a vector. What do you mean by vector addition, vector subtraction, vector multiplication? Can we do vector divisions? So all those things we will be learning in this particular area. Second important concept which we'll be learning is the calculus. So when I say calculus, people will be a little, this is a daunting concept, especially for me when when I was doing my schooling or college, because this was very tough to understand, like what is happening, and generally we were mugging up the formulas. If somebody asked me like what is d by dx of x square, I would have mug up and then I've told it is 2x. But I really couldn't know like what was the intent of this, right? So if I'm saying like why I'm saying like d by dx of x square is equals to 2x, I'm not understanding why this kind of thing was coming up. Of course, my teachers were very intelligent, and they made me understood, but that age which was very difficult to understand what was the reason this is happening, right? So in data science, what we are trying to do is we are trying to do optimizations. Now, what is an optimization? Optimization is trying to get the best of accuracy, accuracy. We want to get the least of error. So the best of accuracy, the least of error. So whatever we're trying to do is we are trying to obtain a minimum or a maximum condition. So this in an optimization world, we call as a minima or maxima. So we are trying to find a minimum or a maximum condition of a certain thing. And when we are trying to find out this minimum and maxima, we're trying to get to the lowest point, right? So whenever we want to find out the error, we want to get to a lowest point. Whenever we want to find the accuracy, we want to go to the highest point. So the process of going to the lowest point or the highest point is typically termed to be as an optimization technique. And the journey of going to the least error, right? So least error is basically the lowest amount of error while I'm doing the prediction. So prediction is all about there is some y value, and then you are doing a prediction y hat. I can say this is called as actual, and this is the predicted. And what we are trying to do is we want to make this actual and predicted as close as possible. If these are as close as possible, my error will be minimum. So my error, generally, the error is the term which is nothing but y minus y hat. My actual value minus my predicted value. How much I am doing it, that would be your error. And my focus would be to keep it as minimal as possible, so that our model will be very accurate. But for doing that, I have to apply optimizations, and a special approach in which you try to find out this least error is by using differentiation. We will see an examples of how we will try to differentiate certain cost functions. Now, this differentiation of the cost functions is trying to get you the small change. For example, when I draw the graph of your x square, graph of your x square will be a parabola, something like this. And if I try to draw the x and y axis, now what is this x dy dx of x square is representing is a small change in your unit value of x will impact a 2x change in the unit value of your y. This is your y, which is your x square formula, and this is your x, which is the units of x. A small change in the unit of x will give a 2x change in the unit of y. That is what this particular differentiation is meaning. It means that if I move one step to the right on the x-axis, how much I will move in the y-axis is the question, right? So that is 2x times. So, and slowly if I move one step further, then you would be moving 2x times on the y-axis. This is how you will be moving 2x times on the y-axis. That is what this talks about. Likewise, there are different mathematical functions, different mathematical forms. If my data is in this format, then this differentiation is pretty easy. But the data will not be in this format. It could be circular, it could be having multiple different forms, it could be zigzag. A portion of that could be a parabola, a portion of that could be a straight line. So likewise, there will be a lot of patterns in which the data could be forming. And combining all the patterns, we are trying to find out the slowest point or the meest point by which we will be using the concepts of differentiation and other things. We will look at the concepts of gradients and how the gradients will be providing us the least error, and the calculation measures for those least error. All those things will be considered. The third one is the statistics. Now, I'm kind of combining the mathematics and statistics here. We will take a completely separate module on the statistics, but statistics will also form a very important role. And specifically, there are two major areas. There is descriptive. There is a descriptive statistics, and there is one more thing called as inferential. There's a descriptive statistics, and there is something called as inferential statistics. Just a second. So there is descriptive statistics, and there is something called as inferential statistics, where the descriptive statistics talks about something like this basically talks about how we are trying to describe the current data. The data is already done. We have already considered the data. Data is already taken. We have collected the information and other things, and now we are seeing like how we can basically describe that particular data. We will take some metrics like mean, median, and mode. We will take some metrics like standard deviation, variance, and other things, in which we describe the current state of the data. The second one is the inferential statistics, where we will try to use the concepts of extrapolation, where we will have some data, we will use the data and then extrapolate the results to the future thing. Now, doing some tests, so we'll take a sample, we'll conduct a test, we will create a hypothesis, we'll try how good the hypothesis is. So there are different kinds of tests which will be conducted on your sample, and if the sample is trying to match to your population, then what we try to do is like we will say that okay, whatever results of the sample can also come in the population, so that we can take the same kind of cases. So descriptive and inferential statistics, again, two important concepts. We will take a separate sessions for them, but they are also related to some of the mathematical concepts. One other area which is also very common is called as probability. Now, probability talks about what is the likelihood of an event happening. Now, this is a very important when coming to the data science, because all we are doing is we are doing predictions. Now, if I'm predicting something, for example, I look at a medical record of a patient and I say that there is a likelihood that this person is having cancer. Now, you're saying that this person is having cancer and you're saying there is a likelihood. But the big question is, what is the likelihood and how much are we correct? Right? If your answer is wrong, then it could lead to a bigger problems, right? But the question is, what is the likelihood and how often are you correct? Now, I could be correct 50% of the time, I could be correct 70% of the time, 85%, 90%, and so on. So if I'm correct 90% of the time, then there is a lot of certainty, saying that okay, there is a lot of certainty, definitely whatever I'm trying to tell, it's most certain to happen. Then our weightage to that prediction will be more. So if I'm saying like 90%, there is a chance that this person, looking at all the previous records, this person can have cancer and so on. Then you're very certain. But if you're saying that 60%, I feel that 60% there is a chance, rest of the 40% there is no chance, then the certainty is decreasing. So whenever we are doing predictions, our certainty of doing the prediction should be very high. Probability plays a high role because humans do not want to have these random information, random results, right? They don't want to have these random results, and probability is nothing but that making sense of that randomness. We want to get some output of that randomness. So we are trying to do predictions which are kind of futuristic thing, and we are trying to achieve that information, but we are also attaching that to the probability angle. We are trying to associate the results with the probability nature, so that, and we are seeing that okay, if this person is having say cancer, this is the probability of person having cancer, looking at the records, looking at the health records, right? So we will look at some of the examples in the probability also. We'll see like how they will help us to do the predictions, and how they will help us to associate the results with the predicted values, so that we will be very certain when we are giving these predicted results. Fifth area is called as numerical operations. So numerical operations, here we will have multiple different things. We could do mean values, we could apply exponent, we could do logarithmic transformations, we could do sine functions, tan h functions. You could do minimum, maximum. There are different things which could be applied on these numerical operations. Likewise, all these numerical operations are part of your mathematical functions. Now, there will be some combinations also. For example, there is a function called as sigmoid, which will help us to find out the probabilities. A sigmoid goes something like this: e to the power of x divided by 1 plus e to the power of x. Now this is called as a sigmoid function, and the sigmoid function will help us to predict the probabilities of the output. Now, and this basically is giving us a lot of predicted values, and a lot of outputs are given, and now this kind of a curve would look something like this. Right, so it goes from -0. Sigmoid goes from 0 to 1. It goes from 0 to 1, and this one will be at 0.5. The central points will be at 0.5. All the data will go from 0 to 1. So when the data is going from 0 to 1, any data will be having this probabilistic number. Anything less than 0.5 will be taken as negative, and anything greater than 0.5, the probability will be taken as positive. So we will see some examples on this, like how do I use this, and we will understand these concepts in a much more detailed manner. But for now, in our session today, what our focus is, we are trying to look at these different concepts. We are trying to see like how we start understanding mathematics. We will understand the linear algebra, and specifically we'll talk about scalars, vectors, tensors. We will take matrix examples and how these matrix operations happens. We will also talk about something like distances, distance-based metrics. We will talk about linear regression. How do we apply linear regression for different topics? Especially, we will be focusing on the calculus part, differentiation, and how do we find out the cost function, the slope of the cost function, the minimal point of the cost function, which is called as the local minima. So those all topics will be covering after that. Then we will be getting into the statistics. Specifically, we'll be talking about descriptive and inferential statistics. We will also touch about probability, and in the end, we will also look at different kinds of operations, numerical operations, which will be performed, because all these are number data. So I'm doing a lot of transformations, lot of mathematical functions. So those all things will be covered. So let us try to create a kind of a mind map of how this entire stuff would be looking like. So I generally create a mind map. So we will start with math for data science, and then we will look at statistics. Then we'll talk about Python. So in the math for data science, we are looking at differentiation. We are looking at matrices, operations, and a lot of other things. And statistics, we are looking at descriptive and inferential. In the Python, we will be looking at a lot of libraries, specifically NumPy, Pandas, and you would also look at something called as and Seaborn. So these are some of the important libraries we'll be looking at, and then we'll start building the tree. Now this I'm calling it as a mind map. So slowly what we will do is we will try to look at some of the concepts of supervised ML, supervised machine learning. Within the supervised machine learning, we have again two different areas. One is called as classification, and second one is called as regression. In regression, we have different other things. I could say like branches, right? So linear regression, multilinear regression, support vector regression, random forest regression. Now, don't worry about these words and other things. We will slowly understand. In the classification, again, we have different kinds of use cases, algorithms which will be used. So we will use basic ones like decision trees, k nearest neighbors, random forest, support vector machine. We'll use XGBoost. We will use logistic regression. So different kinds of models are there which will be used, and what this will help us is we will try to grow the tree and try to create these use cases of different classification and regression. But the solid foundation will be on the mathematical topics. We will have a solid foundation on the statistical topics, the Python and other things, and then we will build this tree. The classification. So this entire stuff will be falling under the supervised machine learning case. There is a branch which will be evolving from the supervised machine learning, which is called as reinforcement learning. Right, this is a little advanced toward the supervised machine learning. So we will have deep Q learning. You will have the mechanisms of rewards, penalties, and so on. On the right side, we can say like we would be learning about unsupervised ML. Within the unsupervised ML, we have different cases like k-means, hierarchical, market basket analysis, principal component analysis, and so on and so forth. We have different other modules like deep learning. In the deep learning, we will be talking about convolutional neural networks. We'll talk about recurrent neural networks. We'll talk about multilinear perceptrons and how to use multilinear perceptrons for doing classification and regression, and so on and so forth. We would also talk about NLP. Especially in NLP, we will talk about text processing. We'll talk about sentiment analysis. And so on. We have another branches which will be like advanced ML. We will be talking about recommender systems, time series forecasting, and so on and so forth. So this should give us a full kind of a mind map or a tree or mind tree. We generally call this as a structure in which we are going to look at these concepts. So we are building this math for data science, the topics for today, and then we will be getting into the statistics for data science. Then we'll be going for the Python. This becomes the foundation. This become the foundations for the course, and slowly we will start building the tree. We will first start on the supervised machine learning. We'll go to the classifications, regression algorithms, build projects on these use cases. Then we will go for unsupervised machine learning, create some projects on this. Then we'll go to NLP, then we'll touch about deep learning, advanced machine learning topics, and so on. And all these things will basically create a holistic approach about how we deal with these different machine learning projects, right? So today's topic, I just wanted to introduce you to these areas of different mathematical concepts, and then I also wanted to get into the linear algebra, but we took a little more time. So we will start this linear algebra as a fresh topic tomorrow, because it would involve in talking about different kinds of vector, tensor manipulations, and so on. So I will spend few more minutes. So that's the reason we will do it tomorrow. But today we also looked at what are the different topics of calculus and statistics, probability, numerical operations. And one important which gives us a holistic picture is we looked at this mind map, the data science mind map, where we are trying to see in one single picture that what are we going to cover in the entire area, right? So any questions? We will try to take some questions if you have. So if you have any questions so far, please let me know. We will discuss about that, and then we'll come back tomorrow and discuss about linear algebra. Do you have any questions? You can use the chat window. I would recommend using the chat window and asking questions. If you have a bigger question, you could use the mic and ask, but always recommended to use the chat window because it would be much more easier. Are you guys following the topic? Is the speed okay? Is whatever we are doing right now? We're going a little slow. Apologize because there are a lot of people adding every day. So I want to accommodate all those things. So we're going slowly, little slowly, but in the coming days we will speed it up so that you will understand in much more deeper manner. So we talked about optimizations. Now optimizations is finding the accuracies and the least error, and finding the best suited values. There are a lot of hyperparameters which are need to be tuned. So we need to do something called as hyperparameter tuning. All these things comes under optimization. So we are using mathematical equations. So all these things are mathematical functions. Now I will calculate the error function. We will try to derive like how the error function would look like, and then we'll try to optimize the error function and then see like what will be the minimum values of that error function. So those things we will look in the coming days. But basically optimizations will mean that it is nothing but we are trying to identify the minimal points for those data so that we kind of achieve the parameters which are causing the minimal points. So there are a lot of coefficients, there are a lot of hyperparameters which need to be obtained to get that minimal point. So by doing the optimizations, we are trying to focus on what those hyperparameters are, what those coefficients are. So once we get the coefficients and the hyperparameters, using that coefficients and hyperparameters, we can construct a generalized formula. So machine learning is all about finding that formula, finding the right set of coefficients which will be contributing to your output. So by doing these optimization techniques, we will find those minimal points. At this point, it will be maybe in a raw format, but as we go further, we will see in more detail like how those are used. Right? Any other questions?
Sitaram, one question, Sitaram.
Yeah.
Yeah, for today, are we covering everything, or are we pretty much done for the day?
We are almost done.
Okay, thank you.
So there could be question like whether this course is complete. So this course is having a very sophisticated curriculum. We are going to cover a lot of depth and breadth of data science, and this certainly would help you to get into interviews. And we would also give us a preparatory sessions on how to face the interviews and what questions will be asked in the interviews. We will kind of get a checklist of different sets of questions which will help you when you're attending the interview. So going before the interview, you need to thoroughly go through the question and answers, and then that will help you to crack the interviews better. But this entire syllabus is self-sufficient because we have huge coverage on the syllabus, which talks about a lot of different areas. So length and breadth is covered in the syllabus, so that should be good enough for the course. So there is a question that are we going to talk about big data related stuff? I will be touching upon a few big data related concepts, but this is not a big data course because the big data will be covering a lot of areas like Hadoop, Spark, and data processing, data engineering, data ingestion. So those are some of the separate topics that will take another few months, like at least 2-3 months for covering that topics. So if I go covering everything, it will take a lot of time. But I will talk about how these things are linked. So now I need to know like how the data is ingested, how the data is processed, and how it comes to a data lake. So we will pick, data scientists will pick the data from the data lake, but the purpose of the data scientist, data engineer, the big data related guy, is to bring the data to the data lake, process it, and then keep it ready so that data scientist can consume it. So we will talk that handshake, like whatever is the handshake between a data engineer and a data scientist, we will understand those concepts. But basically we will not be fully covering the course on big data. That's a completely different course. That is not the scope of this particular course. Right? Any more questions? So what we'll do is we'll come back tomorrow. I'll ensure that I set up the system. There's some problem. We took a few minutes for setting up the system. But I'll ensure that the system is proper. I'll create it ready. So we can have a proper session tomorrow.
Yes, thank you.
All right. Thank you very much. I'll come back tomorrow at the same time and we'll discuss linear algebra, and we'll slowly discuss about other topics in the coming days. Till then, take care. Bye bye.
Sure.
Thank
Bye.
you. Thank you, Sitaram.